Alright, you guys know I'll be out next day, right? Wednesday. I started the recording. I should be saying it. I didn't mean it. Yep. All right. A few things about this class. Okay. Uh, there's got a few things about the class. So, what is going on homework-wise? Which homework that you guys are doing? Is it the for loop or while loop? Did I upload the while loop homework?
I didn't see the while loop.
I was wrong.
I didn't. Okay. Alright. Okay. Okay. No problem. So I do have two homeworks for while loop. Okay. There will be no class on Wednesday. Uh, and after this while loop, the only thing that we'll be covering is uh, what is it called? The equation. Okay. So basically, symbolic equations. That's what they call. So basically, you'll be solving algebra by using the octagon method. Okay. So that's the last thing. All right. So basically, what is that we have done after the midterm then? Highlight wise, selection structure. Remember if else switch case, right? Those things. Highlight, very important thing. Then we started for loop. We spent quite a bit of time, like 2 weeks on that. Quite a bit of time we spent on that. We started while loop already in last class, right? And then while loop has like 2 more classes, right? But I'm gonna try to see because we're gonna be missing the next class. I'll try to I'll try to possibly condense it. Okay. So the idea is would be having one class at the end of 14th week for the review or talk about the whole thing, what happened after midterm. Okay, so it could be helpful for your final exam. Now, I have two options. Since I'm not doing the final in class, right? It's take home, you know that, right? I can split it and make it half of it in class during this semester and half of it take home, or I can do the whole thing as take home. Which one you prefer?
Do the whole thing.
Whole thing?
I'm fine with that.
Don't do anything in class.
How long do we have to do it?
Huh?
How long do we
Is it
have
like
to
a
do it?
time thing or like?
No, it is. If it's take home, I will probably adding some more questions, some difficulty level I'm gonna add. You understand obviously, right? Because it's take home, and I'm gonna give you like the weekend probably, or the way it's gonna work is the last class, like that Wednesday of week 14. I'm gonna give it to you after the review class, right? A review or something, discuss about the final, and then I'm gonna upload it. Actually, it will be uploaded before. I'm gonna make it available to you, okay? And you will gonna have until Monday. So Monday next week, because this exam is supposed to be on Monday. The final exam is supposed to be on Monday for this class. Okay, so that's why this should be due on final week Monday, as if like you are doing the exam during the final week, not necessarily you are done before that. Okay, you understand? Everybody understand? So everybody in consensus. So homework wise, let me again refresh. So you're gonna have 3 more homeworks. Okay, you understand? 3 more homeworks, one take home. So 2 homeworks for the while loop. I'm gonna upload it immediately after this class. Okay. So basically the last one, which would be the symbolic math, right? I'm gonna upload it when I come back. Okay. Most likely not even next week. Next week would be what? Week 13?
Yeah.
Yeah,
Sounds right.
yeah. So,
Is there
yeah,
is there gonna be 2 homeworks and no practice, or 2 homeworks and
two
practice?
homeworks and two practice. Now, what do you wanna do? Like, it'd be probably too much, right? In short period of time. Maybe I'm gonna give you one practice, I guess,
Okay.
and 2 homeworks. How about that? I don't wanna overburden you at the last moment. Okay, this is week 12. You should be relaxed on this class. Everyone understands so far everything, right? Without any issue. Everybody's good. All right. So yeah, I don't wanna overburden you. All right. So again, two homework, one practice. Okay, and then it will be uploaded today, and it will be due end of next week. Let's put it this way. And next week on Monday, again, I'm gonna wrap it up. This thing. You understand? This while loop. And next week on Wednesday, I'll start a symbolic math, and I'm gonna possibly go 2 class, like Wednesday week 13 and week 14 day 1. Okay, and then week 14 day 2 would be as I was saying, like kind of a review and give you like make it available to you the final. So you can see the final in front of me. You can ask me question or anything, whatever, right? So you have access, right? You have access of me to ask me any questions with the final and everything. All right, that's the plan. I guess that's a good plan. Let me know if you have any issue, question, or whatever. Let me start with our agenda today. So I have to put my notes on. Okay, so we are doing for loop part 2. Okay, sorry, while loop part 2. All right, what you gotta do usually. Title, description, those things. Let's start writing them. Let me make it a little bit bigger so you can see it better, I guess. Okay, so yeah, hopefully this is better. Okay, so while loop, right, part 2, and it needs to be all together just to follow the norm of this October MATLAB that the space is not allowed, you know that, right? And the description of that, obviously would like to explore more examples, okay, with while loop. All right, and then obviously would like to write this way main code. You guys remember on the header what else you gotta put usually? Like the email, the date, your name, also the institution, those sort of things are so important. So CLC clear all, right? Close. Sorry, Octave doesn't have this clear all command. Usually MATLAB we used to write clear all, but clear is fine. Okay, clear. What does clear do? You remember, right? It clears up all the variables in the variable window, right? Remember, Jason? Clears up. Okay, and then obviously close all, right? And then let's start with the actual thing. So when to use, like you have kind of seen it already, like the for loops and while loops kind of do the same thing. Now question is when to use what, right? I mean there are instances where you can use both for the same thing without any effect, but there are occasions where you'd like to strictly stick with the while loop, right? It's like the thing that you can do by while loop is the same thing you can do it by for loop, but the thing that you can do it by for loop not necessarily can serve the while loop. You know what I'm saying? So while loop is a little bit advanced. So while loop can deal with the for loop for sure without any issue, right? But for loop, it's difficult for the for loop to deal with the while loop things. As you know, in while loop you can put conditions, right? In for loop you can't. Indirectly you can, but usually you have to define at the beginning how many times the for loop you would like to run. In while loop you don't have to define it that way. You just have to put a conditions. Until the condition matches, you should keep running and running and running. So that's the main difference, right? So let me put it this way. So first of all, the universal rule, right? So use the while loops. Okay, use the while loops when you don't know the number of iterations, right? That's the universal rule. Ahead of time. And for loops, when you do know the number of iterations ahead of time. Okay, that's the basic thing, right? Okay, obviously our goal is to explore some more examples, possibly some advanced one, because we didn't do any advanced application yet for the while loop. Okay, we just had the basic idea. Like remember the loop counter. Everybody remember the loop counter. Okay, so that's what we have used so far. Okay, so item counter, another thing that we did in another example in last class. Jason, you watched 2 video lectures before coming, the classes that you're missing. Okay, all the classes, right? Okay, okay, make sure you do so. Okay, so other examples, even if you miss anything for both classes, like you have the opportunity on Wednesday, the whole day there won't be no class from me. So like 4 hours you have, you should catch up. Okay, with any class that you missed, because everything is in Brightspace, the video lecture. All right, so other examples, so use a for loop. Okay, I mean, let's try to make an example, but let's try to establish some criteria. So again, usually we use the for loop to iterate over an array, right? And then let me put some more pointer here. So when you know the number of times, as I mentioned it, right, number of times, right, in for loop needs to be executed, I mean, you know, executed, you know, when you define a array, right, you need to know how many elements on that array. So usually for loops is better for those kind of thing, right? And for while loop, right, use a while loop. I'm just establishing a situation when to use what, not necessarily this covers everything. For reading a file into a variable, okay, when the increment value is non-standard, okay, you know, for while loop, for for loop standard, for loop, what you do usually, I, j, k, l, m, n, whatever it is, equal 1 colon some value, right? So for loop, it just goes with interval of 1. In while loop, you literally have the control. Say like the I values could gonna increment with a different value than 1. So you can do that. Even in a for loop, you can do it as well. There is a system for that. It's like it should be I colon that interval colon the final value. But usually you don't do it. That's not the convention, okay? For while loop, you would like to do it if it's not non-standard increment. When asking for user input, right, that for that occasion while loop is more convenient. So if you don't know, that's one of the more I'd like to go with the next line, I'm sorry. All right, if you don't know how many times, that's the main highlight here, how many times or how many iterations are needed, okay? That's what the main motivation for you to use the while loop. If you don't know how many times you gotta do the iterations, okay, you gotta use the while loop, okay? All right, so these things I put it here from a book, and the book reference I have it here from How to Pick Between a While and For Loop by Jonathan Su, Better Programming, and it was published. I do have the website address for that. Let me put it there. So you should be reading more info from there, okay? So the source for this thing is Jonathan Su, if you're interested to read it more. So how to pick between a while and for loop. And the name of this book is Better Programming. It's published in February 14th. I do have the website link as well. You should be exploring more. It's free. 2020 https://bit.ly/3kknihcx. All right. Just the reference. The reference thing you don't have to type. If you are interested only, then you can type it and explore it later. Okay, but let's deal with the example. So far what we have seen, like difference between while and for loop, when to use the while loop, those sort of thing, the application of the while loop, all sorts of things. Okay, I have a first example which is a simple series with while loop. Now when I'm saying series, so far you had quite a bit of experience with series in homework and in class, remember, like harmonic series, regular geometric series, and the series that we would be exploring today called Fibonacci series. Everybody is familiar with the Fibonacci series? You do? Some others from math class, it's a very popular one. So Fibonacci series, the way we're gonna deal with this thing here in while loop, we're gonna establish a criteria obviously to run the series element. Okay, would be establishing as well as the equations for different elements of the series. Okay, in Fibonacci series, the element 1 or the first element would have a different equation than the second element, and consecutively the other elements. Okay, so we'll be seeing all of them. So let's start with that further ado. So creating a while loop, okay, to generate the Fibonacci series. Okay, now the variable that I'll be defining for the Fibonacci series is fib1, fib2, those sort of thing. Okay, fib1 is the first element of the Fibonacci series, fib2 is the second element of the Fibonacci series. So I'll be writing this way, like on a fib1, right, equal input, and then you'd be writing what input? You'd be writing please. You remember the input function. It would be asking you here to get a value, and you'd like to store it in fib1. That's the variable name. Okay, everybody got it? Those are the things you guys are familiar. Ben, you're good? Okay, Jason, good. All right, so yeah, you'll be asking the user, so please enter the first fib value. Don't worry, I'll talk more about the Fibonacci series. For now, just think this way. You are defining this fib1 and fib2 as these first two variables of Fibonacci series, right? And then I'll be asking kind of the same way that the second value for the fib, right? I'll be doing a little shading here. This will be the second. Okay, so the second Fibonacci value, that's you're asking from the user, right? Then create a while loop Okay, so create a while loop to generate the Fibonacci series. Okay. Why I'm doing it? I've done this thing before. I'm sorry. So I equal. Let's initialize the parameter. So I equal to 2, right? And that's what I'm doing. Like I'm initializing the loop parameter. All right. And then let's do it while fib I is less than 100. So this will keep computing, okay, until the value fib I is greater than the value, okay, and then fib I plus 1 is equal fib I plus fib I minus 1, and then this I equal I plus 1, and then you're gonna end this. Let me write it first, the whole thing, then I'm gonna start explaining. So figure 1, and then you'll be doing a polar figure, and it'll be much easier. I'll talk more about the polar figure as well, just 1 second, to see the results on display first. Okay, sorry, just 1 second. So this is week 12 lecture 1. Let me save it somewhere, right? Okay, so yeah, that's it. So what you are doing here, you're initializing the I parameter I equal to 2, and then first of all you are asking the user the Fibonacci series first two values. Okay, that's always the case for Fibonacci series. You gotta define the first two values. Based on that, the other values and the series will gonna always get defined. Now how is it gonna get defined? By this equation here, the equation that you are seeing here, fib I plus 1 equal fib I plus fib I minus 1. What does it mean? That the third element would be the summation of the first two elements, the elements that you define, right? So like you define the first two elements 1 and 1. The third element would be what? 2. Say like the first two elements you define 2 and 3, then the third element would be 5. You understand that? So that's how the Fibonacci series works. Now how it works in the while loop, you are first saying, okay, do it for first 100 elements for Fibonacci series, right? Alright? So why you do have to do 100 elements? So that you do have a good plot, so you can see how the series progress, right? It could be any number, by the way. So then, see, I already talked about the equation for the third element, fourth element, and the series other numbers, right? After the first element. Now it needs to be progress. The way it progress is the last line in the while loop, which is I equal to I plus 1. What is happening here? You keep increasing the index number for I. Okay, by doing this I equal to I plus 1. And you are initializing, that's another very important thing, you are initializing I equal to 2. Why? Because take a look here, if you don't initialize I equal to 2, then on the equation itself, when it runs for the first time, it would be fib 0. Do you have a value of the fib 0? Why I'm saying that? If you initialize I equal to 1, then 1, on the equation you're seeing fib I plus 1 equal fib I plus fib I minus 1. So if I was initialized as 1, so this I like 1 minus 1 would be 0, right? That would be fib 0. You didn't define fib 0. You defined fib 1 and fib 2, right? Fib 1, fib 2 is the first and second element of the Fibonacci series. Understand? So that could be a problem. And that's the reason you define this I equal to 2. Everyone understand this? You might have to do this kind of thing in any other series that you'll be solving, right, in your homework or practice. So that's why I kind of explored this thing in detailed manner. Now obviously you'd like to display it in a polar plot. You didn't see polar plot before, did you? Anyone? No? The polar plot is like in a plot, like it goes around a circle. Does it make sense? Now obviously the values got increased, right? Because you will keep adding the last two elements for the next element, right, for the Fibonacci series. So since the values get added, you guys ever seen snap? So it will gonna look like snap, right? It will gonna increase like this. Make sense? And that's what the polar plot is gonna show. That's why you're doing the polar plot. And the structure for the polar plots is very straightforward. Like you'd be doing like x and y, right? What would be your x? You see, x would be your I, and this final I would be what? Once you're done with the while loop, you have the final I value would be 99 or 100, whatever you have defined on the condition, right? And then you're saying your x would be 1 to 99 or 100, say like 100, okay? And then 100 would be 100 because I to I plus 1 is set that. So 1 to 100, and then you have the every time the fib value will increase corresponding to the I, you have this fib matrix element is going to get stored, right? So you're as if like you're is assigning on the polar plot x comma y, where x is the matrix, y is the matrix, right? In this case, y is like the fib matrix, right? X the matrix, you are defining it 1 colon I. Does it make sense? You could have defined that 1 colon I because that's a matrix, right? Then 1 colon I is what? Like interval of 1. So 1, 2, 3, 4. So it's a matrix. You could have defined it before polar plot. It doesn't really matter, right? But you are doing it inside this polar plot. So you are skipping one step, which you should be doing, right? When you be writing the program. Like you should be a little advanced on those kind of things. Anyway, after all those things that I explained, you are running it, and then it's asking, it should be running it, and it should be asking you some values, say like 3 and 5, right? And then okay, and here's the thing. So you are seeing this angle in terms of 360, right? It started from 0 because remember I said like polar plot is circular, so like 0 to 360. And these values that you're seeing here, it got increased for each of these I value here. So okay, I did one mistake. I'm sorry. I was talking about the I value is up to 100. It was not I value. I put a condition fib, the element value less than 100. Okay, I didn't put I is less than 100. That's why I don't have that many, right? So as if like when the fib final value on the matrix is less than 100, then it says let it stop. It makes sense, and you'll be seeing the result here as well, right? So in the command window, see for the final fib that you're seeing here, right, where you have 89, but why do you see 144? Because remember, as if like I was explaining it in last class as well, right? So it will gonna, when it is less than 100, right, it will gonna stop running as if like, but the thing is it did run one last time already here. That's why the values actually goes 144. And what happened when the while loop will gonna try to run again, because the fib last element is 144 already, it will gonna see okay 144 is less than 100, so it will gonna stop running. Does it make sense? This one is a little tricky to understand. Let me know if you have any question on that. All right, so that's that. That's the first example that I have for you guys today. And since there is no class, right, I'll try to cover as many as possible until you guys get bored, right? I have a second example here, which is another series called geometric series, right? And I'm gonna explain everything about the geometric series, how does it works, right, on the notes here, and then I'm gonna run the code for the geometric series, and then possibly we'd like to take a break, right, a little bit, because our goal is, remember, like when I'll come back on next week on Monday, I would like to finish the while loop, right? So there is like part 3, part 4, we are only part 2, okay? So I'd like to start with part 3 as much as I can. Is it okay, guys? A little bit longer class today. All right, perfect. Everything's good so far? Any question? Okay, perfect. All right, so another example like geometric series that I was saying, let me start giving you the description of the geometric series, what this is, and hang tight for a long notes, okay? All right, so you should be typing as speed as you can. I'm gonna give you time to catch up with the writing. So there are many examples of geometric series. That show up in math and nature. So examples include repeating decimals, Archimedes, quadrature of the parabola, fractal geometry, and even in economics, where they are used to represent the time value money. Basically, this is just the intro. Where do you see different series problem? But let's talk more about the geometric series problem that we'll be solving here. So we will compute a simple geometric series using the generic formula for the sum Okay, for the sum of the first n terms of a geometric series. Okay, so you have this a plus ar. I'm now writing a geometric series ar square plus, okay, dot 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 ar to the power n minus 1, right? So that would be the sum from k equal 0 to n minus 1 of ar k equal a multiplied 1 minus r to the power n divided by, that's the nth number, right? That's the equation for that, 1 minus r. All right, now I'd like to pause here again. What did I do here? So as giving you some intro about different series, and series could be naturally occurred in different phenomena, as I explained before. And then I was talking a little bit about the geometric series. First, starting with the geometric series definition itself, which is a plus ar plus ar square plus ar n, and then to divide it in while loop, you need to know how to define the n term, right? I give you the equation for the n term here. You can understand the geometric series, right? It's not that difficult to understand. Let me know when you're done. All right, so whereas so let me start with that. So r equal input, and then writing please enter a decimal between 0 and 1, and then you are defining a equal input please enter starting constant, and then you're defining epsilon equal 1 10 to the power minus 6, and that's the criteria for convergence. And then you are defining few more variables like geo equal a multiplied r square 1. By the way, this r is the input function that you had it defined before for the value of this r variable. The geo is defining one of the element of the geometric series. It is a r to the power 1. That's the first element of the geometric series. Okay, and then you'll be writing the notes as like you are calculating. So calculating the first value of the geometric series, right? You guys notice here, right? You define a and r. All you did, geo equal a multiplied r to the power 1. That's what you write. And then you define another variable called geosum. What it be doing? The geosum, we're going to initialize the variable to hold the sum terms, as if like we've been doing it quite sometimes, right? In previous class, we always define like total equal to 0, then total equal to total plus 1, or total plus I, something like that. We have done it before. So geosum is something like that. So it's a placeholder. It will gonna initialize the variable to hold the sum terms. So you're gonna initialize the variable to hold the sum term. Then you'd like to define another variable called geometric. So geometric is equal geo. Why you are doing it? Because you are creating a matrix to record the values for plotting. Okay, you'll be seeing the geometric geosum, those things later in the while loop. You'll understand it more, but for now understand this epsilon is the convergence criteria, so important. Okay, we've done the convergence criteria in last class, right? When to end the loop, so it's for the condition, and you have defined this R and A initial for the initial or the first element of the geometric series, right? And then you write this geo, which is the first element for this series equation, which is a r to the power 1 for the first element. And after that, the final thing would be the k, which is the loop parameter, loop counter. Remember that? So k would be k plus 1 inside the while loop. So you'd be writing initialize the loop parameter. So that's what you're doing, and then you started writing the while loop for the first time. So while absolute geo is greater than epsilon, right? Remember you had this epsilon, EPISILON. Make sure this epsilon is matching with the other epsilon, and remember the geo is your first element, right? And then you would be running this until the epsilon value is smaller than the geo value, and then let's start writing this code. So geosum equal geosum plus geo. Again, the geo is the first element, remember that, and then you are adding the new terms, and then geosum, remember you initialize is 0, and then this geometric, remember you did define geometric. Geometric is creating a matrix for the plotting. The geometric k is your variable. Remember you define initial as the loop counter, and then you are defining the geometric is geosum. So then finally you are adding this k equal to k plus 1. You are adding the loop counter. So let me put this note here. So incrementing loop parameter. So if I'm gonna give you a little bit more, you gotta do it because we already have the first element or first term. Okay, so we need to calculate the next term. So then this is where the magic happens. Geo equal a multiplied r to the power k, and that's the next term, right? Now you did define the first term before you started the while loop, okay, by defining the a and r, and then to the power 1, which is geo. Now every time the loop will gonna run, it must needs to get updated, right? And that's what it's doing it here. Geo equal to ar to the power k, and then you are computing the next term in the geometric series, and then you got to end this while loop, and then you'd like to plot it, right? It would be difficult for you to see the series component, so you'd like to define the geometric equal geometric k, element k equal k minus 1 plus geo. So what you're doing here, by doing this, you are adding the last value. Okay, the last value of the geo, remember geo last value is what? A r to the power k. Alright, so and the last value, and then remember you already have one figure, so you'd like to define it under figure 2. So what you're doing here, you're plotting the sum as a function of term number. So plot 1 colon length geometric, and then geometric, then line width, comma 2, and f print f. You are not basically plotting the geometric series, okay? And the plot function is doing what, like, you know, you have this first matrix which is 1 colon length of geometric. Now the geometric is a matrix, remember that, right? So length of geometric, we're going to define how many element in the geometric matrix it does have. Everybody understand this, right? The length function, everybody remember? Ben, you remember the length function? Jason, a good length function, right? So that's as if like just in plot you have done it before. Two matrix, right? X and Y. If X is matrix, Y is a matrix. So the first matrix is 1 colon this length geometric. Okay, that's a little tricky to understand. So length geometric is defining the number of elements. Okay, so like as if like you're defining a matrix by doing another function inside this plot. Okay, so it's a little tricky to understand. Just let me know if you have any question on that. And then obviously geometric is your matrix where the final results are, right? So that's your y in a plot x and y, right? And the line width is optional thing. You can add it, not add it, doesn't really matter. Just to remind you like how to deal with those. Okay, then you'd like to display the results, right? Fprintf is always for displaying the results. So the number of for convergence, right, is remember fprintf, you'd like to do it like, you know, percentage of 0f, don't put like O instead of 0. /n is for new line, right? And then you'd like to show the value of the k. So k is number of times it needs to run it, right, for the convergence. And then this fprintf, right, the series converges to percentage of 4.4f when the common ratio is percentage of 0.3f. You remember 0.3 means 3 decimal places, right? Percentage is the pointer and f is for the decimal number. Okay, and remember that percentage of anything, I write percentage of point f or percentage of f, or that is for the variable pointer, right? For the first fprintf we had k, that's why we write percentage of 0.0f. In the second one we had this, like, you know, more thing to display, where I would like to display the series convergence happen when, like, you know, percentage of this 0.4f is doing that, that would be the geosum. And then you have R and A. One is for the common ratio and another is for the constant. Okay, you'll see it once you'll type the whole thing, you'll see the whole picture, then you'll understand it more. So 0.2f are used. Okay, and then you have a /n, right? And then this is so important. Now you gotta define the variable. So geosum comma R comma A. So those are the variable, and then you'd like to end this. I know this one is a little tricky to see it, the whole thing. You'd be seeing it now. Okay, I'm saving it. What we should be seeing a very nice plot after typing all of these, and this one is really difficult compared to whatever you have done so far, right? The geometric series, doing it in a while loop. Probably the most difficult one we've done so far, right? Let me see if I can give you more understanding on that. Finish the writing, we'll do the plotting, and we'll talk more about it. Okay. What is the time now? Is it like we're done into 1 hour? 11:53. Okay, we make 1 hour like break, right? For 5 minutes or so. Because remember, I have 2 more parts, so maybe I'll cover a little bit more right today. That could be helpful. So I can finish everything in a while, but that's on Monday. it running for you guys? Do you have a plot? Just trying to understand what is happening here. Okay, first focus on this Q. Before you go writing the while loop, you define what? Like the first element of the geometric series. You understand that, right, Jason? There is a geo, which is a r to the power 1. You define a and r. You are asking you here, give the input, okay, using the input function. Alright, so now, once you have the first element, can you give some more time? Alright, run it. I'd like to explain it to everyone. Just one time. This one is a little tricky. I bet you're going to understand once you're going to read through it. Can you understand this whole thing? It's a little complicated, right, compared to any other thing that we did. Is it running for you, Ethan? You have a plot? Error! I don't like error. Can fix it or you need my help?
Probably fixed it.
Okay. Okay, let me see if I have an error. Did you define the decimal value point something? Starting constant. Okay, I do have an error as well. Jason, you have an error?
Yeah,
Okay, what is that? It says unknown line provide unable to create graphic and let me see.
We'll run your line code back up. Run your code line back up. So that way you can figure out exactly what's causing it. It's a lot longer.
Let me see what is happening here.
Once it throws up an error, database will show the line that's causing the error and like where it's causing the error. In this line is causing the error, basically.
Alright, so
Sometimes it says line provider in that as well.
alright, I have at the value of geometric geo. Is it working for you, Jason?
no.
It's not working for me as well. Let me try to fix it. Ben, it's not working for you as well?
No, it's not. It says line is missing line.
Alright, so let me see what I can do. So it is working for whatever reason. It was not working over there, but you see when I copied it and create a new one, Ben, you see I did just copy it and put it in a separate file, and it's working perfectly fine. So there is no error on the code at all. You see that? So it says the number of number for the convergence is 13. Okay, so correct it. So the number of k, there is a typo, number of k for convergence. Please add the k here, the thing that I highlighted. The series convergence to so then let me save it and run it again. So it's asking the value from 0 to 1.5 and enter a constant, say like 5. Alright, so the number of k for the convergence is 23 in that case when I define it this way. And then the series convergence to 5, which is the 5 value, you see the final value, when the common ratio is 0.5 and the 5 are used. Okay, so you see the first value and the second value for R and A, that's what the common ratio is, the R, and A is 5. That's what the value is, A. That's what displayed here. All right, so again, Ethan was here. So again, I don't know what is happening over there, but it is clearly running. And if you are having the same issue, just do it as like mine. Okay, create a new file for the second problem, because remember the Octave does have this weird issue, right? I don't know why. It's a free program, open source code sometimes act weirdly. All right, but this code is perfectly fine. You have seen it, so make sure yours one is running the way I did. I just open a new editor, okay, and what I did, on that editor, on the new editor, I put CLC clear and close all those three things first, okay. So the memory you're gonna get erased, all the figures you're gonna get closed, and the command window you're gonna get cleared out. And then I wrote the same thing. I just copied and pasted here, and it's perfectly working fine. All right, so again, Octave is free, so we gotta sometimes. Is it working for you, Ethan? It was not working for me. Then I had to copy it and paste it in a new window, and it's working now. I don't know, for whatever reason it's not working in me. Is it working for you? Was it working? It is working very fine. I don't know. When Octave is free, sometimes act this way, right? Anyway, so as you say, the code is perfectly fine. The thing that I wrote, you make sure yours one is running as well. You copied that thing in a new editor, and then.
I mean, it's not showing the graph because this computer doesn't like the graph. But other than that,
You're still without the graph, right?
I know my numbers are right.
Yeah. So yeah. Right. So we are facing like different kinds of problems. Okay, so I gotta do a little bit of grading. Did you upload all these things? 9, 10?
There you go.
I didn't do any grading. So I gotta do it. Okay, so I promise you guys. So what will happen after this class? I'm gonna finish all the grading after this, whatever you say, and upload this to me homework and then practice problem. Okay? It was good.
And they'll be collectively due
Um, Sometimes when I'll come back.
sometime.
And
Okay,
and with it.
understood.
By the end of next week.
Yeah, and with it. And this thing, whatever you submitted so far, I think it gets stacked up here a little bit. Let's do it. So I'm gonna grade everything. Okay. Come back in a few minutes. Okay. The third example that would be doing the projectile motion, and then would be ending the class. Okay. All right, I think it's time. Let's start. So example number 3. That's the last example we'll be doing here today, okay? So this is the projectile motion. So projectile motion. We'd like to define the constant. So define the constants first. Projectile motion, what is the constant? Would be following the engineering format. You remember the engineering format? Like the Givens, finds, those sort of things. What is the constant for projectile motion? Like the g, right? The g is the gravity, so that's the value you know already. By the way, you'd like to put a, sorry Jason, I just started I wrote just 2 lines, projectile motion and then the constant, okay. This ay is negative, and that's the last example we're doing, Jason. So once we're done, then we're done, okay. Free for today. And then, okay, so just putting it somewhere here. All right, so then the givens, define the givens, and what are the givens? First of all, the angle theta. I mean, it's the same problem that we used to do, right? Remember, we had the time value with the time matrix 0 to 100 seconds, right, with interval of 0.1. We had the theta, which is 30 degree, the projectile angle, and then the initial velocity was 35 meter per second, right? And then you got to plot this x and y, right? The motion of x and y. That's what we used to do, but we'll be doing it in while loop for the first time, right? We haven't done it for while loop. We've done it for the for loop. We've done it for the plotting. Okay, so many things. The matrix chapter, but this is the same problem. We'll be doing it for while loop. All right, let's start. So theta. So the theta value was 30. The same value I'll be using here. This is the angle for the projectile. I won't be writing all the detail because we have done it so many times, right? The same problem, Jason, right? This projectile, same thing we've done so many times. All right, so we'll be just simply writing without the comments, but I'll be expecting if you are answering the question, you'd be putting comments, right? Because I have done it so many times, I'm just skipping some of these comments here. And obviously, I'm gonna bare minimum keep the units. So the second is the second for the time matrix. And the initial VO is again the initial velocity, which is given as 35 meter per second. You'd like to put the unit, which is meter per second. You want to put another unit here as well, which is theta is the angle is degree, right? And then you have this XO, which is the initial X location, and the unit is you'd like to put the unit obviously in meter, right? And then you have YO, again is 0, right? Which would be again unit is meter, the initial Y location for the projectile X and Y. Basically it starts from the origin, in other words. And then J equal 1, you're initializing the loop parameter. So initialize the loop parameter. That's what's so important to understand, loop parameter. And then this X, the first element would be equal X0, and Y1 would be Y0. Okay, then the time 1 equal T1. Okay, and then you are writing the while loop. So write the while loop. So you're writing while y j is greater than, so that's the condition you are putting. So basically the y matrix value, when it is more than 0 or equal to 0, until then you write the loop. And then you are defining j. Remember this j is the loop parameter, j equal to j plus 1. You can do it before or after, really doesn't matter. And then you'd like to define the x and y equation. So I forgot to put j inside, so it should be j. And then the x equation is x0, okay, xo I would say. So vo multiplied by the T matrix. Remember, you don't have to put a dot when you are defining the individual element, which is Tj. And then this cos d. Remember, when you have the angles in degree, right? Then you should be using the cos d instead of cos. Cos is for radians. And then you'd like to put a unit of meter. We've done this problem so many times. You have done this problem for homework, so I'm kind of not explaining too much on this aspect. Only thing here to understand how to put the while loop condition, why to put this condition, right? In for loop even we did the same thing. All right, so then obviously for y you have this yo plus vo multiplied t, then j, then the whole thing is multiplied by sine d, theta plus 0.5 multiplied ay multiplied tj square, and this the unit is in meter. Then you have this time j equal tj, that is building a matrix of the times we have used. Now you can plot it by using this plot function, just like the way you did before, which I'll be doing actually anyway. So this would be your figure 2. You had a figure before, I had a figure before. Oh, so that one is my figure 2, right? So this one should be figure 3. Alright, so then you'd like to plot it. So like plot x j. So plot x j y j. Okay, and then you'd like to put O as a marker, right? And marker size you'd like to put 10. So marker size make sure M and S are capital in marker size, otherwise it will not gonna work. 10, and then you'd like to use this axis just like in last class, right? The for loop we have used this, the same thing. All right, I mean we are doing exactly the same thing what happened in last class, except we have the while loop, okay? And then you have this range 0 to 124x, and then 0 to 24y. You can change the range based on the results, and then hold on and draw now. Why you are doing hold on? Because you see after the one dot or marker is done on the plot, we would like to hold on for the next time the while loop will gonna run, right? That's why this hold on function is here. I shouldn't say function, hold on command. Okay, the draw now command is kind of the same thing, right? We are drawing every time the while loop is running. And then you'd like to end this while loop, and it should be running with the plot. So I'm going to save it. I'm going to try to run it. 1, 2, 20. All right, so you see that's the figure you should be expecting, and I'm going to come back here again. So this code is running perfect. Now if you're done typing everything correctly the way I did so far, you should be able to see a perfect code. So what is really happening? You see, the while loop, I put a condition that the y value, remember the projectile has x and y value, right Ben? The projectile has x and y coordinate. When the y value, as long as the y value is more than 0, that program should run. Now, you have to understand the projectile has an angle of 30 degrees, right? Okay, Jason? So if it is going 30 degree and you have seen it in the plot, you're going to go up, you're going to come down, and it will going to hit the ground, and you're going to try to penetrate. When it is going to go under, that means is the y value is negative, in negative territory. Okay, so in that case, okay, you're saying okay, stop the program. Okay, so that's your condition, and that's the only thing different from last class projectile motion problem. Then you understand, right? That's the only thing difference that we did here, the condition on the while loop and initializing the I or j. What did we use here? I and the j, right? So that's the only difference here. So we initialize j, the loop counter, right? Remember the loop counter, Ben? Yeah. Inside the while loop, we're adding the value of 1, okay, in the loop counter, and we put a condition in the while loop. Okay, we're saying the y value, remember Ben, the y value can't be when it is going to stop, the y value can be negative. So when the y value is negative, stop it. In other words, the projectile is going to come from 0, 0, right? And they're going to try to penetrate the ground. That means the y is going to get negative, right? And then it stops. So that's it. And the other things like the draw now, hold on. Hold on function, you guys remember that we started that thing in the plotting. Can you remember the hold on function? Oh, I would say it's in the function. It's not a function, it's a command. Okay. The hold on command, what does it do? The common application of hold on. See, if you have a plot, Jason, and you plot something, okay, and you would like to plot on the same figure against something else, right? Remember in some figure you've seen like multiple plots, right? So in that case you'd like to use the hold on. In this case the hold on you are using because you have, you see, every time this thing run, you understand, Ben? You have that marker is your plot. Makes sense? That one single marker is one plot. So you keep doing it. Another marker, another. Draw now is going to do that. The draw. Okay. Is it running for you guys? The hold on draw now.
No, I got an error.
The code is running perfect for me. So if you're going to make sure the code is auto complete properly. What something? Oh. It's running now. Even the second program is running for you. Is it running for you, Ben? You understand the hold on, draw now, all those things that we did here. Why I did that? You understand the while loop condition? Anyone of you have any question with the condition that I put? First flip value. Where is the flip value? Wow.
So that's in there.
Yeah, my code is running perfect. So
That's just for question two.
in
right?
question 2 we are having issue. I was having issue as well. So what I did from question 2,
Yeah,
I copied and pasted somewhere else, and
So
then
should I delete this?
no, I open a new one.
Yeah, I have it right here.
Yeah, you have it.
So should I delete this one?
No, because it does have this, first one, right? The Fibonacci series. You don't have to delete. Those are
No,
most-
just this from here to here. Since I already have it right here. I haven't saved it.
Alright, so don't delete it. Open another editor file. So that one is for what? Like second one, right?
This is the
third-
second question.
So is the second one running from this editor file?
And this one, yeah.
Yeah, it is perfect. Okay, so then for the third one, you'd like to delete it, and then you can do it the way you want to do. So like maybe like part 2 of this lecture of with 12 lecture. That way you can save it. It's up to your choice, right? Yeah, small V, I can see that. You define a small V, you put capital V over there, right? It should be changed to capital V. Now what? Theta, December. You have the just do capital T. Then there is a practice that you should be started doing. So T, there is still the T. That when you start typing some variable, it is gonna give you the suggestions. You should press enter instead of typing the whole thing. Otherwise, you will be doing the same thing. It should be starting from 0. I don't know why it starts from 10. But just make sure that you define that value is 0. That's 0. Anyway, so that's it, guys, from me today. So what I promised, like immediately I go home. I said at home, in the office, and then I'm gonna grade everything that whatever you submitted, and then upload 2 more homeworks and more practice problem. I'll see you on Monday. Any question? It's good. Ben, you're good now. Yeah. You want me to explain one more time? You see what happened here on the condition?
No,
The-
yeah, I got it.
You got that part?
I was just seeing.
Have a good one.
You too. I'll see you guys next week.
Yeah, I'm just lunch too, so. if she fails on assignment 2, I'm actually gonna throw a fit. I swear to God.